Okay, so probably we can start with the last presentation of this workshop today. So Marc is going to talk about structural change, land use, and urban expansion. You have 45 minutes. Please, go ahead.
All right. Hello, everyone. I'd like to start thanking Alessio, Fabio, and Vincenzo for organizing this, and especially including our paper. So this is joint work with Nicolas Cordassier and Florian Oswald. Florian is here, I think, so any difficult question will be answered by him. And it's still very much work in progress. So we didn't have time to do everything we wanted before the workshop, but anything, any comment or suggestion is going to be very welcome. I'm going to motivate the talk with some pictures from a region in France called Reims. This is Nicolas' hometown, but it's a good reason to use that town because it kind of illustrates part of the work we did for this project, and it also captures the main trends we want to emphasize. So if we look at Reims in 1866, we can see that the region is mainly still agricultural. More than half of the workers are farmers, and the town itself is very small. This orange dot would be Nicolas' birthplace, or this is where he grew up, and it's very much on the border of the town, right? If we check again in 1950, we can see that the town is much larger. And now Nicolas' place looked almost like central. And in 2015, it takes almost the whole space, and Nicolas' place is in downtown. Okay, so it's a good example because it illustrates that with the process of structural change, there is this big increase in the size of cities. In the case of Reims, it gets multiplied by 25. And this is lower than the average French city. And this compares with the increase in population, which is about threefold, right? Meaning that urban density has been falling a lot with this process, okay? And related to that, we do observe that the value of land has changed, but this is especially the case in the recent years, right? So housing prices and so on have been increasing a lot, but it's mainly a recent period. Okay, so in this paper, what we want to do is basically to introduce this special dimension into a kind of standard general equilibrium model with structural change, and we want to focus on this idea of land use. What are the implications of land use? And also, what are the implications for a structural change of taking into account this dimension? Okay, so we're gonna have, I'm gonna go to the model later on, but it's gonna be a model with three sectors or three goods. There's gonna be a rural sector and an urban sector, but also a housing sector. Okay, so land, which is gonna be in fixed supply, is gonna have to be used either in agriculture or housing, assuming that urban production doesn't take much land. There is going to be this kind of competition for land between the two goods, right? And then as agricultural employment falls or rural employment falls, we're going to have this expansion of cities. And the way we're going to generate that is because people are going to try to live close to the urban production centers, which are going to be in downtown in our model. And this is going to generate these cities around these centers. Okay, so that's kind of the idea. If we think about this, the last 150 years or even the last 200 years in France, I think we can divide this period in like three stages or three sub-periods, and then you can try to see what will be the role of land in those periods. There could be an old period in which the economy is basically agricultural, and since land is an input in agriculture, land is kind of scarce and it has a high value. So cities are going to be very small, but also density is going to be very small because land is going to be expensive. Okay. Then during the transition out of agriculture, we're going to have that the growth in agricultural productivity is going to make land more abundant, meaning that the prices in terms of agriculture would actually fall. And this is going to make possible cities to expand without an increase or a large increase in land values. Okay. And then as this transition out of agriculture is almost over, and as in the recent times, we're going to have that the demand for housing goes up if income goes up, and then land values are going to start rising. Right. So that will be a little bit of a summary of the mechanism in our model and how can we explain these different subperiods. Okay. So, well, why do you think this is important or useful? First, with this framework, we're gonna be able to understand the evolution of land and housing prices over time, but also across space. We're gonna try to, at some point, do some regional comparisons. And this may be interesting to understand the housing crisis or other current debates. Also, the idea of sprawling, when do cities expand and when does density fall? And finally, this framework can be used to study other things, like another explanation for city growth could be the fall in commuting cost. So we think of this framework as also being a tool to understand in a general equilibrium context what will be the effects of commuting costs falling, or for instance population growth. And then we can also use this framework to understand what would be the effects of some restrictions or policies in terms of land use or height, building height, and this kind of stuff. Okay, so I'm not going to get into the details of the related literature. We have here many papers, and I'm sure there are many others that I didn't include related to different fields of the literature, like urban or macro. More related to this workshop, it's very related to the structural change literature. In particular, there are a few papers that talk about structural change and urbanization. Here, our emphasis is going to be really on this land use decision, and this is something that we think it's not out there in the literature. Okay, so after this introduction, I'm going to start with the three sections. First, we're going to talk about the historical evidence from France. Then I'm going to present the framework. And finally, I'm going to talk about the quantitative analysis. For the moment, I'm going to refer to it as a numerical illustration because we're taking most of the parameters from the literature. We only have one city and so on. We're working on a richer model with multiple cities. And we hope we're going to be able to estimate some of the parameters using the data. All right, so let's start with the historical evidence. So we're going to take data directly from other sources in terms of employment, land values, land use, and so on. Our contribution in this part is to document the change in the size of cities, and this is going to make us possible to compute the change in urban density. Okay, so in France, I guess, as in many other economies, agricultural employment was very high in the 19th century. So here we have data since 1830, and it was around 60% agricultural employment. And nowadays it's around 2.5%. And together with this fall in the agricultural employment, we see this fall in the share of land used in agriculture, okay, which according to our data goes from about 67% to around 52, 53%. Okay.
Then, Marc, can I ask you what's the size of land used in cities? Do you know? It must be kind of like small, no? Or...
Yeah, I think nowadays it's around 10%, 12% in France. So there are other things, yeah. So we could, in our model, we don't have it, but we could incorporate, I don't know, lakes, forests.
Yeah. But it presumably has gone up, though, right?
That's kind of an issue, whether we have this increase in forests and so on. I think it was not a big change, but yeah, it's something that to take into account.
I think it actually it has doubled the amount of forest in France since late 19th century, something like that.
I don't know. Yeah, it could be. I mean, if you just check here, I mean, more than 65 was in agriculture. Now it's still 55, maybe 10%. City size, I don't know. So there is 30-40% that is other stuff. Mm-hmm. Maybe it has increased a little bit, but it has to be small.
Because I guess the trade-off, you know, like you want to, at the margin you decide, no, like whether you want the land for agriculture or for housing, no, or if I understand.
Yeah, we don't have this decision at the moment.
Oh, I see.
Maybe at some point we want to think about other land use.
Okay, sorry.
I mean, one comment, at least in the Brazilian data, we found, for example, a large increase in the amount of land that was devoted to forests. So there is this, and I think in Europe that's the case, no? In the last century, a lot of land that was used to agriculture is now, has been reforested. So I think it would be nice to have also a measure of the urban land. No, I guess you can get that from because governments classify land by their uses. No, so there's some land that if you want to, make urban constructions, it has to be classified as urban. So you could get a measure of how much is the land that is classified as urban over time.
Yeah, so I guess we can do that because we measure the size of each city. But my feeling is that I don't think it changes much in terms of the aggregate, because here I was checking the numbers. If it's 65, let's say that the urban was 3 or 4%, 70. Maybe it has increased a little bit. So it's a good point. We should, I guess, do something with that. But so probably most of the fall, I think, or the number we have in the paper is that about 2/3 of this fall in agricultural land goes to urban land. I think about 2/3. That's the number we have, I think. Yeah. Okay. So so then about the city size. So here where we compute the areas of cities in 1866 and then again in 1950, as I showed you for REMS, we see that on average it gets multiplied by 8. Okay, so it's a huge increase in terms of the areas of cities. I would repeat again the same between 1950 to 2015. We see that again there is a lot of growth, and it's a factor of 6 for this period. So in total, it's almost 50. That's what I was saying, that in REMS is actually lower than in other towns. Okay, so it increases a lot. Then it's true that the urban population also increased a lot, but not as much, right? So if we compute the average urban density, it is a big fall. And this is the case in all cities, right? It's a similar pattern in all cities. In the case of Paris, for instance, we can also see in central Paris, and what we see is that there is also a fall, although it's not as large as in the overall city. Right? So part of the adjustment in density is going to come from this new part of the city. But there could also be adjustments in kind of the old city, right? And then, so finally, let me show you this plots on the evolution of land values and land wealth. If we compute this kind of the total value of land, housing plus agricultural land over GDP, it's rising in the recent period, but it fell for a long time, and it was pretty flat for a while. Okay, we focus on agricultural land; it's been falling for the whole sample period. Okay, this kind of shows that the housing wealth is increasing, which is consistent with this last plot I have about the housing prices. Right, some people refer to it to the hockey stick shape because they look pretty flat for a long time, and then they've been rising fast. Okay, so I'm gonna now switch to the model, but for the moment, what we're kind of trying to show is that the framework I'll present is consistent with this idea, in which this relocation of land allows for cities to expand without large increases in land price. Once this relocation is over, then prices are much more affected by the increase in housing demand. Okay. So the model is quite simple. There is only kind of all workers are ex ante identical, and they're going to be working. They're going to be choosing where to work and where to locate. Land is going to be in fixed supply, and is going to have to be allocated, as I said before, right? So the decision is here. The decision here is going to be between the rural sector and the housing sector, because we're going to simplify things and assume that the urban sector doesn't use any land, only uses labor. Okay. What else do we want to say? So then the housing sector, we're going to model it as using this intermediate good to produce housing services. The intermediate good is going to be the urban good. And then what else? So we have perfect competition, a perfect mobility, as I said, and no trade costs. So basically, prices are going to be the same everywhere for the urban and the rural good. Okay. So in terms of the production functions, as I said, only labor for the urban good. This LU denotes the number of workers, and theta U would be the productivity in the urban sector. So urban workers are all going to be paid this theta U. But then, as I'll mention later on, they're going to be commuting costs. So the kind of the earnings net of commuting costs are going to be different depending on the location. In the rural good production function, here I am allowing for this sigma to be different than 1. So there is agricultural workers or rural workers, and then there is land. I'm using S for land here. In my numerical illustration, I'm going to have sigma equal to 1. And but again, if we allow for complementarity, as I think Paolo was saying before, it is something that we've tried. If employment and land are complements, then we even have a stronger effect, right? Because then when workers reallocate, the fall in the value of the agricultural land is going to be even stronger, and then it's going to allow cities to grow even faster. Okay. And then in terms of the housing sector, as I said, it uses land and urban good, and it produces these housing services. We're writing it here as in terms of this housing supply elasticity, because that's a parameter we want to calibrate later on. We can think of this production function as being a Cobb-Douglas with labor and land. Then if we write it kind of the cost of providing housing services at a given land unit or a given location, it will be given by this, where H denotes, capital H would denote the housing supply. And this parameter epsilon, which is the housing supply elasticity, it shows how much the cost increases. Okay, so this is going to be key for us. If we have low epsilon, it's kind of costly to build, and then city is going to have to expand more. On the other hand, if epsilon is very high, if it's very large, the cost of building is low, and then it's possible to have like huge towers everywhere. We don't need cities to expand too much. Okay, that's the idea. There is some evidence that this housing supply elasticity may depend on location. So near the city fringe or the city border, it may be higher than in downtown. It's kind of intuitive. It kind of makes sense to think that it's harder to build in places where it was already built a long time ago. because you have to either remove what's there or you have to do something to increase the height. We're going to also try, we're going to have the two simulations, one in which epsilon is constant, another one in which epsilon is lower at the city, is lower as we get closer to the city center. Okay. Then we generate structural change because of these normothetic preferences here. So we have that the utility or the consumption composite depends on the rural consumption, the urban consumption, and the housing services. They're going to be location specific, and this parameter C bar, it denotes the subsistence level, and it implies that the expenditure shares for the rural good are falling, right? So the income elasticity is low for the income good, for the rural good, sorry. Okay, this is what's going to generate structural change, right? So in particular here, because with these preferences, what we need is agricultural productivity change. Then the question is whether we're gonna, when we simulate the model, we're gonna have that both sectors have the same productivity growth. The question is whether with other type of preferences we could get different results. For instance, we're experiencing with when we also have a kind of a constant term with the urban good that some people have tried, kind of an endowment of urban good or something. Then it's also possible to generate structural change with that. And then urban productivity matters for structural change, but then the issue is that you generate completely different predictions for density and so on, right? Because then the housing, the income elasticity of the housing good is much lower, right? Okay, so then in terms of the budget constraint, as I said before, so P, which would be the relative price of the rural good, is the same everywhere. The urban good is the numerator, so the price normalized to 1. And then the price of the housing services are location specific. Okay. In the next slide, I'm going to be more clear, but basically some locations are better than others in the urban sector because you're closer to the production center. Okay. And these earnings are also location specific because we're going to have, because with this we denote earnings net of commuting costs, right? So if you're far away from the workplace, you're going to have to pay a high commuting cost. If you're closer, you pay less. And this little r here denotes the land rents, which are distributed equally among all workers. All right. And so in terms of this spatial structure, we're going to denote the city center as location 0. Then we can think as the whole country as being this interval between 0 and 1. What's key is that the urban production is going to take place at location 0, right? So then if you live in location 0, you're not paying commuting costs. As you move far away from location 0, then you're going to start paying commuting costs. And basically at some point, the city, there is the city border, the city fringe. After that, it's going to be a rural area. And rural workers are not going to be paying any commuting costs, are going to be working where they live. Okay, so this phi here, we're going to use it as the city size, and it denotes the kind of the border of the city in this line. All right, then as I was saying, so workers are exactly identical, so everyone is indifferent where to live. So the utility they get must be the same in all locations. With this utility function I was using, I presented, we can show it's equal to this, where this kappa depends on the parameters, which shows that differences in earnings after paying the commuting cost are going to be compensated by this term here, which depends on which is the housing price. Okay, so as I was saying before, closer to the city center, you pay less on commuting costs, but then this is going to generate higher housing prices. All right. Prices then are going to fall as we move away from the city center until we reach the city border. After that, it's going to be constant because then location is not going to matter at all. And then what we get is that in terms of wages, what's going to be equalized here is the rural wage. Okay, so the wage paid to farmers with the wage net of commuting costs paid at the fringe, right? So then with this model, we generate this kind of gap in earnings that some people in the literature have referred to as this agricultural productivity gap, right? So we're going to have that the wage in the urban sector is going to be higher, but here everyone is going to be identical and so on. It's just because of this idea of the commuting cost, right? So the marginal guy is going to equate the highest commuting cost times the wage to the rural wage. Okay. So graphically, this will be the description of the housing prices, the rent. So this is a rental rate. So, and as we can see, the housing price falls until we reach the city fringe, and then it's constant in the rural area. Okay. So to summarize, in equilibrium, so we have all these parameters that are the production function parameters, the preference parameters, and then there are the commuting cost and this housing supply elasticity parameter. And then after choosing those values, we're gonna solve for the equilibrium variables, which are gonna be the labor allocation, the city size fee, and then rural land. There's also going to be housing land in the rural sector, but it doesn't. Yeah, so it's also going to be endogenous. Prices and these land rents. Okay, and as I said, there's perfect competition, and so all factors are paid their marginal product. Workers are indifferent across locations. The size of the city is endogenous, and it has to satisfy the demand from urban workers. All markets clear, and also land rents are endogenous. Okay. So I don't know if I have some time for this. Yeah, so let me try. So one way to think about this equilibrium. Sorry?
You have 20 minutes.
Okay, so let me try to. One way to think about this equilibrium, I don't know if it's useful or not, is there are two equations. One that tells us what's kind of the equilibrium number of workers given the city size, and the other one that tells us what's the city size given the number of workers. As we increase the size of the city becomes less and less attractive because you have to commute more, right, to go to work. That will be the red line. On the other hand, as we increase the number of workers, we need to expand the city because we have to put them somewhere, right? So for instance, what I was saying before is that if this elasticity is very high, so if housing elasticity is very high, we're going to have that this blue line is very steep, right? And then we're going to have that there is less city expansion and so on. Okay. On the other hand, if we for instance, if we ignore the fall in the rural land, which we could think of a partial equilibrium or some other stories, then the blue line it will be, so before I said steeper, sorry, I meant flatter. No, steeper as well. Yes, sorry. Then this line would also be steeper, right? If we didn't take into account this the fall in land prices that I said before. Similarly, if we decrease the sigma, which will be if we make land and labor more complements in land, the blue line would shift to the right, which would make cities grow more. Okay. So this would be well, and then there is this other parameter, which will be the commuting cost, right? So what happens as we increase the commuting cost? So it's likely that cities are gonna be larger because basically now workers don't care so much of living far away. So both lines would actually shift a little bit, and cities are gonna grow more. So basically, what we're gonna have here, we're gonna have the parameter that's gonna be changing is gonna be productivity. And then when there is productivity growth, what's going to happen is that, in particular, agricultural productivity growth in this setup, is that workers are going to try to relocate to the city. So at any city size, there are going to be more people interested in living there. there could also be changes in this blue line, but the main one is this, right? So as we increase productivity, we're going to have more workers in the urban sector, and then we're going to have larger cities, right? Depending on the slope of both curves, we could have a fall or a rise in density, right? And yeah, and also in equilibrium, the change in both variables depend on these slopes. Okay, good. So let me now discuss a little bit what we have for the quantitative analysis, and if I have time, I'll talk a little bit about what we're doing now. So we have to parameterize all these values. So we're gonna have sigma equal to 1, as I said, and alpha 75. We're gonna assume that both rural and urban productivity move equally, but as I said before, in our current setup, the only driver is the rural productivity. We do the preference parameters we choose the preference parameters to get kind of reasonable values for in the recent periods, so low agricultural sector and so on, and then the C bar, this non-homotheticity parameter, is chosen to match the initial employment share in agriculture. Okay, and here productivity, actually we're also playing a little bit with it to get the right labor reallocation here, right? Which basically it's not constant growth. We need kind of faster growth after the Second World War and so on. Then for the commuting,
Marc,
yes.
one thing. So I know that the income elasticity of housing is a little contentious. But
yes.
I think that, well, I mean, I don't know. I think most people are fine with just saying it's just like, elasticity of 1. And so I guess I didn't fully understand what you said when you allowed for like the U good to be more income elastic. Can you explain that, and how, why does it matter that now like housing and the urban good have the same income elasticity?
Yeah, that's a good point. We've been playing around with this a little bit lately, but I don't have it in my slides yet. So as you were saying, Martí, so we have now the current model has the same income elasticity for the housing and the urban good. We check the data. Of course, it's controversial because expenditures are in terms of food, right? So food includes all kinds of stuff, mostly urban good, but it's probably the case that it's a little bit below the urban good one.
Mm-hmm.
So if we have, so basically what would happen? It matters a lot for the urban growth, right? Which is, I'm not sure for this audience it matters so much, but for I think the urban economics audience it matters a lot, right? What happens if there is agglomeration economies and so on? In this context, if we add this term in the utility function, what's gonna happen is that the urban productivity is also gonna have effects in terms of the allocation,
mm-hmm.
right? So in particular, for instance,
those will be like with this like stone gear, those will be temporary actually.
Yeah, I mean,
as you make like the sector productivity increase, they, asymptotically it will be pinned down by the, I guess, gamma.
No, you're right. But for the dynamics, which is basically what we're looking at, this transition period, it matters, right? So urban productivity would then have an effect on the allocation potentially, right? Mm-hmm. And in particular, if there is more urban productivity growth, what's going to happen is that so what would happen is that the effects will be a little bit the opposite, right? So you could also have reallocation of workers, but then since there is so much demand for housing, or the rise in housing demand is not so large, they're going to shrink their apartments, right? And then you would have the opposite effect on density and so on. But it's something we plan to do, right? When I mean to calibrate it properly, we've been looking at that and we've been trying to see what would happen. And I think the main effect is this. Then it's kind of important to get it right, whether it's urban or rural productivity growth. Okay.
Okay, thanks. Thank you.
All right, so for the commuting costs, we're gonna assume they are linear for the moment. And we use this value of 7 so that the city doesn't explode too much. I'll also show you what happens if they had been falling over time. Okay. Of course, I was showing before in this plot, it matters a lot in terms of density, right? Because if commuting costs fall, then people have this. It's not so costly for people to live far away from the city center. And there is this other key parameter, which is the housing supply elasticity. For the moment, we're using 4, which is a little high, I think I would say, in terms of the literature. But we're trying also with this other specification in which it's 4 at the fringe, but then it falls as we get closer to the center. Okay, and in particular, we do it in such a way that it never goes, or that in recent times in the city center is 1.5. Okay. So this is kind of an open door for us. We still don't know exactly what would be the right way to do it, but we've been trying with those specifications. And finally, there is population. We're trying with constant population. If we include population growth, some of the numerical predictions will be a little different. I'm going to show you. In particular, land is going to become more scarce, right? Not surprisingly. Okay, so let's start with these two. Here on the first one, we have agricultural employment and agricultural land. And we kind of match, almost by construction, the evolution of the agricultural employment. And then we get a prediction about the fall in the agricultural land. Okay. And I mean, we do get, it's not too different from the data, I guess. It falls by 15 percentage points agricultural land. Agricultural employment goes all the way from 55 all the way to 2.5, I think. And then in terms of city size, we do get a rise in the size of cities. And the rise is about like fourfold, sorry. In the constant elasticity model, if we allow for this location-specific epsilon, then the rise is much higher, right? It's almost 7 times the rise in cities. If commuting costs had been falling, what we observe is that the rise in the city would have been, in the city side would have been a little stronger, right? So initially the city is smaller because commuting costs are very large. As they get closer to the value of 7, then they converge. Okay, so we do get a rise in the city size, and we also get a significant fall in the urban density, right? So this will be the average on the left. Again, the fall in density is much stronger if we allow for this location-specific epsilon, because if epsilon is lower in downtown, it's very difficult to build there, and then basically the epsilon density has to fall in the downtown. This is what we show in the right plot. So the red would be city center. We have constant epsilon is constant. If epsilon is location specific, density of the city center would fall. Okay. At the fringe is always falling, right? Which is what I was saying before, that part of the one way to match this fall in the average urban density is just from lower density at the fringe. Okay, so the new neighborhoods of the city have lower density than the old ones. Here again, right, if we allow for falling commuting costs, the effects are stronger. So the average urban density would fall much more, but especially in the city center, right? In the city center, density would fall much more. And it makes sense, right? It's not so costly for people to live far away from the city center. So if they want larger houses, they move far away. Then in terms of these land rents, we do get that they are somewhat constant for a long time, and then there is this rise since the second half of the 20th century. If we decompose again fringe land rents and urban land rents, we get that in the city center they're always rising, especially if the city is location specific. But in the fringe, this will the land rent at the fringe are the same as in the rural area. They do fall, right? So for a long time, these land rents fall. Okay, which is kind of this idea I was trying to explain at the beginning, that as labor reallocates, land as an agricultural input loses its value, and then cities can expand more easier and have an easier time to expand. Okay, if we look at the land rent as a share of income, the aggregate will be the red. It kind of fall, and then we get it then to stop falling in more recent years, especially if we allow for this location-specific epsilon. But we don't get them to rise. I'll show you what happens with other simulations. If we only focus on urban land rents, then they, as a share of income, then they are rising for the whole period. So commuting costs here don't do much, but then if we allow for population growth, we do get this kind of rise at the land rent as a share of income, right? Maybe they're even growing too much relative to the data.
5 minutes, Marc.
5 minutes, okay, good. And finally, if we look at this gap between the urban and rural workers, we do have that it's above 1, and it's actually growing in this economy, right? Especially if epsilon is location specific, it gets to almost double during those periods. Right? So this is what some people talk what they mean when they talk about agricultural productivity gap in some articles in the literature. Here, as I was saying before, we generate this just from the fact that there are commuting costs, right? The presence of commuting costs make the marginal worker indifferent, but to make him indifferent, it's net of commuting costs. And finally, if we look at the difference, kind of this will be kind of how steep are these housing prices, the gradient of housing prices. It gets much steeper over time, especially if we allow for location-specific epsilon. Okay, so here, what this means is that if we compare the housing price at the city center with the housing price at the fringe, this increases over time. Okay, so this is what I wanted to say. Just to summarize, we have documented these new facts in terms of city expansion for France in 1860, which allows us to compute these urban densities and the evolution of urban density. Then we developed this special general equilibrium model to explain jointly the evolution of the sectoral location, the density, and land values. And for the moment, all we're doing with the numerical exercise is to show that it's quantitative, it's kind of consistent with the main features of the data. We hope to do some policy analysis and to evaluate the welfare effects of some restrictions or technology changes. But then what I was mentioning before is that one thing we're currently working on is on having a setup with the multiple cities. Okay, the idea would be to have these aggregate outcomes that we have in the one city model, but having multiple cities, it would kind of allow us to have different urban productivities, right? And here it will be important to have differences in urban productivities. If we have urban centers that are more productive, then they're going to attract more workers. And because of our indifference condition, they're going to end up with a smaller apartments, and we're going to generate higher density as it's observed in the data. Okay, so just to show you a little bit what we're doing. So we're splitting the economy in different areas. The rural productivity is the same everywhere. Okay, so if the experiment is to have higher urban density, higher initial urban density, but then same growth everywhere, we're going to have that the green region, the one with the high urban density, high urban productivity, is going to have more workers. It's going to be larger. Okay, but actually we could show that density would actually be higher as well, right? So, and this will be keeping productivity constant. So in this case, total population would be constant. But we could have differences in the evolution of productivity, and this would generate kind of migrations across regions or across towns. Okay, then the other thing we have on the pipeline is to do the dynamic model. It's kind of simple in this context, but it may be important to calculate the purchasing price. For the moment, we're using this the rents. Okay, but if we want to have the prices, it may be important for this, right? And it may not be so obvious in the sense that there could be parts that are not in the city yet, but maybe become part of the city in the future, or there could be part of the city that are kind of far away from the center, but they may become more central in the future, right? So there could be things like that. Well, and then as I said before, our plan is to be a little bit more rigorous in terms of estimating this commuting cost, these commuting frictions. We could even try with nonlinear commuting frictions. And also to have some, we could play around with the land restrictions, right? If using data on land prices and so on, we could try to infer those land restrictions. Right? So there could be restrictions in terms of how much the city is going to grow, right? How much the city is allowed to grow, and then there could be a jump in terms of the land values. Okay, so thanks a lot. This is all I wanted to say.
Okay, thanks, Marc. Is there any question from any of you? Okay, I guess there are no questions. So, okay, let me thank all of you. I give...
there is a question, maybe.
Yeah, the word to... there is a question?
There is a hand by Miguel, maybe?
Oh, sorry.
Oh, I didn't see it.
I see a raised hand in the chat, yeah.
Yeah,
Okay.
Can you hear me? So,
Yes.
so
Thanks.
one question I have about this is that so you're drawing on the experience of France, but so think about a case in which you have an elastic supply of land, and that would be the Netherlands, for instance. Okay, so it'd be interesting to see what happens with the evolution of land prices and population density, city size, etc. In the case of the Netherlands, in which historically they've reclaimed, essentially they've doubled the size of the country.
Yeah, you're right. So yeah, it would have important effects if we increase the the amount of land available. Then this kind of this decision, this land relocation, is much less important. Yeah, so maybe it could explain why they kept such a large agricultural sector. I don't know, but it's true. It would have important effects in this framework because there is much less tension. I would also expect smaller density and so on, right? I don't know if it's the case.
That's actually correct, because I think that this kind of power law city size doesn't really apply to the Netherlands. So you don't have that big gradient in terms of city sizes.
Yeah, so actually, I'm much less worried about the Netherlands than I am about the United States, for example, because the US obviously, particularly in the early periods, and just expanded massively. And so that what you're saying is definitely true. So there, it's going to be very hard to nail our point. That's why we're doing it in France, not in the US.
Yeah. But it's true, it could be interesting to see what happens if we had data for other countries in which, yeah.
Any other question? Okay. Any hands raised? No? Okay. So I thank all of you. I give the word to Alessio for the final greetings. and wait for you in Cagliari next year.
Yeah.
Hopefully.
Thanks, Fabio. So let me thank all the presenters once again and all the participants. I think it's been a very nice workshop. The only shortcoming is that it was online and not here in Cagliari, unfortunately, for everybody, I guess. So there's no, like yesterday, no dinner for us. But yeah, as Fabio said, we hope to have all the presenters here soon physically. So we will postpone the regular workshop to the next year, and we will share the dates very soon with you to check your availability. The last thing is that as we anticipated, we recorded all the presentations, and we would like to put them online, but of course we will ask you permission to do that beforehand, and we hope you will be okay with that, but feel free, of course, to say no. But I think it would be nice for people to have these resources available for some time, at least online. So we close the workshop here. Thanks again to everybody, and even it's Friday, have a nice weekend, and I really hope to see you in person very soon. So goodbye to everybody.
Thank you.
Bye-bye.
Thank you.
See you soon.
Thank
you.
Bye.
Thank
Thank
you.
you.
Bye. Clap to everybody.
Thank you.